Without any further ado, let me begin my presentation. So before I start the talk, I would like to give a quick outline of my presentation. Firstly, I will discuss the background and objectives and scope of the talk. Then I will move on to the methodology, which includes data collection, data pre-processing, exploratory data analysis, feature creation, feature engineering, implementation of machine learning and deep learning algorithms, as well as some interesting results and discussions. So let us begin. We all know that financial data forecasting has been a topic of great interest amongst researchers across the world. It has been quite a complex topic, as we all know, because financial markets are quite complex and it's not very easy to understand them, and leave alone talking about finding trends and predicting them. It is a very significant domain which has a wide variety of applications and consequences. Moreover, every single second, massive amounts of financial information is being generated in the form of stock prices, cryptocurrency prices, foreign exchange indices, etc. Now, if this information is leveraged and converted into insights, it can be very beneficial for both individual investors as well as business organizations, because it can help them make better data-driven strategic decisions. So now, moving on, what exactly is the objective of this presentation? The main aim is to predict and analyze the time series data of selected stocks and indexes through machine learning and deep learning. Now, for those of you who don't know what time series data is, it is essentially the sequential data. For instance, you can take the weather data or our health records over a period of time. So here the order of the data is really important. And in this case, date is the index of the data that we're making use of. So now, time series forecasting is essentially predicting the value in the future based on the value in the past. So we leverage historic data in order to predict something that hasn't happened yet, which makes this so much more challenging. So to give you a quick introduction to what the talk really is going to be about, we will mainly implement long short-term memory on stock market data. And I will be discussing the entire machine learning pipeline with you as we proceed with the presentation. So now a very cohesive methodology was devised in order to predict stock prices in the future. So this includes data collection, data pre-processing, data analysis, as well as sentiment analysis, feature creation, feature engineering, machine learning and deep learning, and finally optimization and testing of the algorithms that we've made use of. So now let's cover each of these steps in a little more detail. First comes data collection. Now, as a part of my research, I mainly collected two types of data: numeric data, which is essentially the historic stock price data, as well as non-numeric data, which is data from the news headlines. So the main reason for collecting two kinds of data was the fact that we've witnessed a lot of real life events in the recent past, as well as in earlier times as well, where certain comments by very eminent personalities such as Elon Musk or Mark Cuban have often resulted in a certain shift in the prices of stocks, because people tend to follow these eminent personalities. Other events such as the sudden rise in the price of GameStop stock prices early this year is also a great example of how news headlines and public sentiments has the potential to drive stock prices either high or low. So I think that's why it becomes very, very crucial for us to have a more holistic approach towards this prediction and include both numeric data as well as non-numeric data. So now, speaking of numeric data, I made use of the Yahoo Finance API in order to collect structured data of 20 years. So as you can see on my screen, the structure of the data includes the high price, the low price, the volume, the open price, close price, and adjusted close price. We will make use of all these values as raw features in our machine learning model, and would also create some new features based on this, which I will be discussing in the later segments of this presentation. So Yahoo Finance API is a free API, so you all can make use of it. And this is daily data, but if you want to use intraday data as well, you can do so. But I think you will have to pay a certain subscription fee in order to get hold of that data. Moving on, speaking about the news headlines, I collected it with the help of Reuters, which is a very popular online news portal that covers a lot of financial news and a lot of events happening in the real life, in the real world. As you can see on my screen, the structure of the data included the headlines, essentially, and also the date on which these headlines were collected. Now, once we collect the data, it becomes very important to pre-process it because the data might contain some sort of outliers or some missing values. So as you can see that I performed clearing of all the missing data as well as scaling of the data using min-max scaler. So now, speaking about missing values, there are two ways to address this issue. Either we can simply remove the missing values, or we can substitute the missing values with the median of the column. So I believe that simply removing the missing values is not a very good approach, because it can potentially lead to loss of some kind of important information. So it's better to replace this information with some kind of median or mean value. Next, I also perform scaling of the data with the help of min-max scaler. Now, once we've pre-processed our data, it is ready for exploratory data analysis. Why this step is very important is because we've collected so much data, but we don't really understand the data very well. We don't know what the data is like, what kind of trends it follows, and what it really indicates. So in order to perform machine learning in the future, it is very crucial to understand the data and to be able to draw important insights from it, so that we can make use of these insights and keep them at the back of our mind while we're analyzing our results, and have a scientific analysis of them after performing our machine learning part. So as a part of exploratory data analysis, I plotted a number of correlation tables. I also plotted a number of graphs. I checked for the presence of competitor firms in the news headlines. And I also calculated the number of news headlines every year, and also plotted some word cloud plots in order to see what kind of words are very prominent in these news headlines. So first comes the correlation tables, and they essentially help us to understand how much a variable is dependent on the other variable. So as you can see on my slide, the more warm colors, the redder tones, depict higher correlation, which means that the variables are more correlated to each other, whereas the warmer colors depict lower correlation. And it's very intuitive because some factors definitely have more impact on the closing price when others don't. And correlation ranges from a scale of -1 to 1, and 0 is the neutral value. -1 depicts absolutely negative correlation, while 1 depicts perfect correlation. Next comes the plotting of various graphs. So as you can see on my slide, I have plotted the 20-year graph of Bank of America stock. So you can see there are certain sharp dips and sharp peaks in the stock prices. And I try to understand why is there such a sharp dip at certain points, or why is a certain peak. So as you can see, before the year 2008, we can see a massive peak. And this is essentially because a housing bubble was being formed in the United States at that point of time, wherein the prices were just increasing. However, in 2008, at the time of the financial crisis, when the housing bubble broke, the stock price instantly fell, and this continued for a couple of years. We can also see in 2001, there is a certain dip, and that can be explained by the terrorist attacks in America at that point of time. So here we can understand that the real life incidents are able to be correlated in terms of the data, and we're able to explain the movement of the data on the basis of certain events in our real life. Next comes again the fluctuations in prices. We can see that the price keeps on fluctuating. So it's not very easy to predict the value in the future because there are so many factors that contribute to stock price prediction. Then, as I mentioned, that I compared the news headlines and I found the presence of competitor firms. So on the left side of my screen is the Bank of America stocks competitor analysis. And we see that other important banks such as JP Morgan Chase, Goldman Sachs, Citibank, and Wells Fargo have been mentioned so many times in the news headlines of Bank of America. And on the right-hand side, we can see the stock for Bank of China, wherein ICBC, HSBC, Bank of East Asia, and Agricultural Bank of China have been mentioned a couple of times in the news headlines of Bank of China stock. This is an indicator of the fact that the stock price of a certain company not only depends on the performance of the company, but also its competitors. And this is quite interesting because if the competitors are doing well, that might lead to certain fluctuations in the stock prices of that specific company. Next, I plotted word cloud plots of the news headlines that I collected to see the main prominent words that have been repeated over and over again. So as you can see, there's the presence of large cap stocks, which essentially means bigger companies which have a higher market value. Then we can see the presence of the country, which is China, and also Asia, and things like these. So these are the common things that people speak about while publishing news headlines. Moving on, let's come to a very important chunk, which is feature creation. So earlier in this presentation, we had noted that we have a number of raw features after collecting data from the Yahoo Finance API, speaking of the historic data. So now that data is definitely not enough, which is why it becomes important to calculate some other indicators from the data that we've collected. So from the news headlines that we collected, we can calculate the sentiment scores, subjectivity scores, and headline embeddings. Whereas from the historic data, we can calculate the technical indicators. And I will be going into some details about these factors now. So firstly comes technical indicators. These are, it's more financial, but I'll try to break it down in simple words for all the techies on this conference. So these are essentially values calculated from the historic price and the volume, and they often form very strong indicators in order to predict stock prices. And a lot of traders and other investors also make use of these indicators in order to find trends in the stock prices. So a number of indicators can be calculated, such as the simple moving average, the exponential moving average, the relative strength index, and moving average convergence divergence. So now Python, beautiful language, helps us calculate all these indicators with the help of very simple mathematical formulas, as you can see on my slide. And going into each of the code snippets for these, you can see how easy and trivial it is to calculate all these complicated financial indicators with the help of Python. So that's exponential moving average, relative strength index, as well as moving average convergence divergence. And all of these have been calculated for a period of 15 days, 30 days, and 45 days. Next comes sentiment scores, subjectivity scores, and headline embeddings. So now, as we've noted through the course of this presentation, how important news headline data could potentially be. And in the recent years, we've seen so much influence in the public sentiments by political party agendas, environmental factors, social media activities, etc. So sentiment scores helps us gather all of this information because we cannot make use of the news headlines directly in our machine learning. We need a mathematical value, which sentiment scores, subjectivity scores, and headline embeddings essentially helps us get. So as we can see that sentiment intensity analyzer helps us calculate the positivity score, the negativity score, the compound score of the news headlines. We also calculate the polarity scores as well as the subjectivity scores. So these essentially tell us how factual the information is. And both these scales, the subjectivity and the sentiment scores, range from a scale of -1 to 1. Next comes Google's universal sentence encoder. So this is actually quite an interesting innovation by Google, and it helps us to convert our headlines into embeddings of 512 dimensions. So basically, it converts every sentence into lowercase and then tokenizes it. Next, the encoder enables encoding of these sentences into fixed 512 dimension embeddings or vectors. And a deep averaging network, or DEN, is the encoder that we use, and it computes the unigram as well as the bigram embeddings and averages them out. These embeddings are used for unsupervised and supervised tasks on the Stanford Natural Language Interface corpus. And the model is then used to map to any sentence into a 512 dimensions embedding. So this is how we create all these three features, which will be used in our machine learning model subsequently. Now comes feature engineering. We have created so many features now, and not all of them have equal importance, and some of them might actually lead to overfitting in our machine learning model. So feature engineering is a very important step that will allow us to reduce the dimensionality and also extract the features that hold the most importance. So I will first discuss the principal component analysis, which allows us to reduce the dimensionality of our data set. And it does so in a way that it preserves the maximum variance and the least information is lost in the process. So as you can see on my slide that I've plotted a graph, and we can see that using 100 features out of the 500 features actually preserves almost 90% of the variance, and thus we can only make use of these features. So this is how we perform principal component analysis in order to reduce the dimensionality. After this, we also perform feature selection. So now feature selection was performed with the help of recursive feature elimination, which performs a backward selection of features on the basis of two attributes. One is the coefficient and the second is the feature importance. And the main aim is to really select a subset of features from the original input data set, which can effectively represent the entire input data set, while at the same time also reduce the potential impacts of any sorts of noise and reduce any sort of complexity or overfitting that might happen. So now you can see on my screen that some features are more important, whereas some features are not that important. So we can eliminate these. Sentiment scores, as we can see, is quite important. Some of the technical indicators are also extremely important. And we will make use of these features in our machine learning model subsequently. Now, there are various approaches in which we can predict stock prices in the future. One of them is a classification approach, and the other one is a regression approach. Now, classification approach will help us to get the movement, whereas regression approach helps us to tell the exact value in the future, and as a consequence of that, also predict the movement. So I did perform a classification-based approach, but I realized that the models are not performing that well because they're quite simple algorithms that were used, and more often than not they were also overfitting and just duplicating the historic data without actually capturing the trends and predicting the value in the future, which is why I resorted to a regression based approach, which will help us to predict the value in the future and also the movement of the value. So our target variable will be the closing price, of course. So now I made use of long short-term memory in order to predict the stock prices. And for those of you who don't know, this algorithm has gained a lot of eyeballs in the recent past because of its excellent performance on time series data. And it is a special type of a recurrent neural network which can handle long-term dependencies. So in LSTM, you can have small altercations made to the information by operations such as multiplication and addition. And this information then flows through various cell states. And as a result of that, LSTM is successful in selectively remembering or forgetting information based on their importance. This is done by the help of a sigmoid neural network layer and a multiplication pointwise function, which helps in deciding which information is actually led through. So I will speak a little bit more about the architecture of LSTM. So I basically made use of an activation function, which was the linear activation function. The loss function was the mean square function. Adam optimizer was used. And in addition to all of these, I also made use of the sequence length, which determines the number of days in past to consider to predict the value in the future. Now, a lot of experimentation was actually performed, and on the basis of different combination of input variables that were calculated in the past. And then we also optimized the algorithm based on 4 parameters, as you can see on my screen, which was very important. And I will be discussing the consequences of optimizing in the next segment of this presentation. Finally, testing, as we all know, is extremely crucial and extremely important. So I performed back testing. And back testing in time series data is actually the equivalent of cross validation for any other data, because for time series data, like I mentioned earlier, the sequence is very important. So I perform back testing. And then moving on from that, let me also now come to the results and discussion, which is a very important part, because we performed all of this implementation to really get some scientific analysis. So as you can see on my screen, that LSTM helped to capture the movement of the data in the long term, although it couldn't predict the actual price, because it depends on so many sudden factors that are not being able to get captured in our machine learning model. So you can see that the overall movement can be predicted to a certain extent, which I think is wonderful. If we compare it to other algorithms such as linear regression, then I feel that LSTM did a much, much better job in predicting these values. Then after that, moving on to the RMSE scores that we calculated in order to tell the performance of our algorithms. So we can see that when we made use of certain input features in our model, then they gave a lower error as compared to when we made use of the other features. So as you can see, if we make use of just technical indicators, then we have a higher score, which means that our model is not performing that well. Whereas if we make use of the selected features after we perform feature engineering, then the score naturally reduces, which is an indicator of the fact that feature engineering can be a very, very important part of our machine learning pipeline. And we should never skip it, because more often than not, we do not perform it because we think it wouldn't impact our model so much. But as we can see, that selected features from dimensionality reduction and recursive feature elimination was actually quite beneficial for us. Next comes optimization. So we kept tuning our hyperparameters with the help of our optimizer, and we were able to generate lower RMSE scores. So our performance did slightly improve after we optimized our model by tuning the hyperparameters. Now, speaking of future recommendations, I think machine learning has a wide application in the financial industry, and it can be applied to so many different fields: fraud detection, KYC applications, stock price prediction, of course, chatbots, sentiment analyzers, and so much more. I think this domain is so wide, and it should definitely be explored in the future, and different applications should come up. Another interesting part is topological data analysis. I wouldn't go into much details of this, but this has gained a lot of eyeballs again because it was quite good in terms of weather forecast in the recent past. So that's also something that we can leverage on in terms of financial data and see what really happens. Maybe this is the next big thing. So feel free to explore this. And since we're running short of time, let me conclude my presentation. So over the course of these 30 minutes, we established the importance of financial data forecasting to make better data-driven decisions. We then discussed the objectives of our study and what we really want to achieve. And then we also discussed the machine learning pipeline in great detail and how we should follow a systematic order and tackle our data well, and also adopt a holistic approach. I think it is also safe to say that stock prices not only depend on past historic values, but a lot of other factors such as public sentiment, political views, environment variables, social media activities such as tweets on Twitter or posts on Reddit. I think these factors should definitely be considered, and combining them with the historic values, I think that's very crucial. And that's pretty much about it. Here are the references that I made use of. Lots of research papers were read in while I carried out my research. So I think that's a good starting point, and all of you should actually start reading research papers. There's so much to explore and leverage from all the work of our scientists. And that's it. Thank you so much for giving me the opportunity. I had a great 30 minutes, and I hope you all too did.
Yep, thank you. Yeah, I think the presentation is very clear and a very good introduction to using machine learning in such an area. May I first ask, did you personally use any Python libraries to implement those algorithms?
Of course, Python is one of the most powerful languages in my opinion, and I made use of a lot of libraries. Firstly, I made use of NumPy and Pandas and Matplotlib to really understand the data. Then principal component analysis and recursive feature selection, all these were available in the sklearn library. Then for the machine learning part, I made use of Keras. So Python has been a very significant part of each and every step in the pipeline, and made life so much easier.
Yep. I think in the chat, Henry Jung asked a question.
Okay, the question is, what is the platform, cloud system, or local machine you're running your ML and AI modeling? Any suggestions in that? Good question. Right now, I am running it on my local machine, but cloud is something that you can definitely leverage on.
Yes, any other questions?
If anyone has more questions after the session, feel free to reach out to me, and I would be happy to answer your questions or have a fun discussion about machine learning, AI, and Python in general.
Yep. Thank you so much. Okay, hope to see you in the conference, and hope you enjoy the conference.
Yeah, I see Chris has asked, can you earn money by this model? I haven't really tried it in the markets yet because I don't trade myself. So I haven't tried it yet, but I think it's quite risky. The markets are quite complex. So like I said, please do your research, analyze your stocks well before investing your money.
So any other questions? Okay, let me see.
All right. All the questions, yes.
Yep. All right, I think that's about it. So, yep, you can find the speaker. I think she generously shared a lot of her contacts. So, yep.
Yeah, thank you so much for giving me this platform, and I had a great time. And good luck to all the Python enthusiasts who are watching this. Yep. I hope you had a great time listening to me. Thank you.
Yep. Thank you.
Bye.
Bye.